This is map 210, and I'm going to do a couple Lumen examples from section 3.1. So what we have here is we want to find the critical numbers of this function here, f of x, and we want to classify them as local max, local min, or neither. And so in order to do that, we're going to do it in Excel. I'm going to do it both in Excel and I'm going to do it by hand. And so in order to find the critical points, we're going to need to take the derivative of this function f of x. So when I look at f of x, the first thing I want to do is to just ask myself, what kind of function do I have here? And I can see, right, that I have a constant times a variable raised to a power, right? And then I have a constant times a variable x raised to the fourth power, and so forth. So this is just a polynomial. And that's important because when I have a polynomial, I know that its domain is negative to positive infinity. And I also know that that means that it's smooth and continuous everywhere. And if I have a function that's smooth and continuous everywhere, that means that I can take the derivative everywhere. It's differentiable everywhere. So f prime of x is never undefined. That's important because we know that the definition of a critical point is where the derivative equals 0 or the derivative is undefined. So I don't have any sharp corners or cusps or points or anything like that. So that helps me out here because if I want to find the max and the min, now I just need to consider where the derivative is equal to 0 because I know I don't have any points where the derivative is undefined. So when I take the derivative, this is just a power function. So when I take the derivative, f prime of x is equal to 30x to the fourth minus 60x cubed minus 60x squared. And so then what I'm going to try to do is see if I can factor this thing if I'm doing it by hand. And I see there's a 30x squared in each term. So I factor out 30x squared, and that leaves me with x squared minus 2x minus 2. And I want to set that equal to 0. And so because I have two terms multiplied, I have 30x squared times this whole expression, I can use the zero product property. So if I want to set that whole thing equal to 0, either this 30x squared can equal 0, or this quadratic can equal 0, right here. And because if one of them equals 0, they both equal 0. So if I take the first term, or the first expression, if I set 30x squared equal to 0, I simplify that, and I find that x equals 0 is a critical point, right? I can divide both sides by 30. This just becomes 0, so I have x squared equals 0, so x is equal to 0. This is one critical point. And so now let's take a look at the next expression right here. So this is a quadratic, right? A quadratic is in the form of ax squared plus bx plus c. And if I set that equal to 0, I can try to factor it, but I already know that this does not factor. I can't factor it. So I'll have to use the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac. So this has got a is 1, b is negative 2, and c is negative 2. So when I plug those values in to the quadratic formula, a is 1, I'm going to put that in for a, and I've got b is negative 2, so I'm putting negative 2 in everywhere I have a b. And actually that c is also negative 2. And then c is also negative 2. okay? And so I plug that in for C. And when I do that, let's just put this back in here. I did not put A is 1 in all those places. And when I do that, I get 2 more critical points. I get X is negative 0.73 and I get X equals 2.73. So here's my 2 solutions, or my 2 roots, or my 2 zeros when I use the quadratic formula. All right, so now let's test those. Remember that all I know is that the derivative is 0 there, so it's flat. My f of x function is flat, and I can't tell if it's a max or min unless I test those critical points. So that's what I'm doing here. I create my number line here, and really what I'm doing is I'm dividing, right? I know that my domain is negative infinity to positive infinity, so I'm going to chop that up around where my critical points are. So here's my critical point, x equals 0, right here. Here's my critical point, x equals negative 0.73. And here's my last critical point, x equals 2.73. And so I want to take a look, I want to understand what's happening where I have an x value less than 0.73, and then I want to see what's happening between negative 0.73 and 0, and so forth. So I'm going to take some test points. So my first test point I'm just going to take x equals negative 1. And so what I want to see is what's happening with the derivative when x is negative 1. And so I'm going to come, here's my derivative formula right here. And I'm going to take my first test point and I'm going to put in negative 1 everywhere I see x. And I see that when I do that, I get the derivative of positive 30. So because 30 is positive, the derivative is positive, that's telling me that my f function, f of negative 1, is increasing. So I'm increasing here. At my critical point, the derivative is equal to 0, which tells me that f of x is flat. Let's take another point here. So I'm going to take a point between negative 0.73 and 0. So I can pick any point. I picked negative 0.5. And so I'm going to put negative 0.5 in my derivative function. Everywhere there's an x, I put in negative 0.5, and when I do that, I get negative 5.625. Because my derivative is negative when x equals negative 0.5, it's telling me that my f function, f of negative 0.5, is decreasing. And then I come to my next critical point. When x is 0, I know that I'm flat. Derivative is 0. Let me take my next test point when x equals 1. So I'm going to input 1 into my derivative function, and I see when I do that, I get a negative 90. Because the derivative at x equals 1 is negative, it's telling me that f of 1 is decreasing. I get to my last critical point when x equals 2.73. I know that my derivative at 2.73 is 0, right? We solve for that, so that my f of x is flat. Now I'm going to take my last critical point, x equal 5, and I'm going to plug 5 into the derivative formula. Everywhere there's an x, I put 5, and I evaluate it. I get 97.50 because my derivative is positive. It tells me that f of 5, when x is 5, it tells me that my function f of x is increasing. And so if I go here and I know that I'm increasing, I know I'm flat, 0, I know I'm decreasing, I know I'm flat. Notice here I'm decreasing again. Then I'm flat. And then I'm increasing here. So if I sort of use that to help trace it, I'm increasing, flat, decreasing, flat for a second, decreasing again, flat, increasing. So At this critical point, I change from positive to negative, so this is a max. All right, around this critical point, 0, I go from decreasing flat to decreasing. This is neither. Look at what's happening around the last critical point. I go from decreasing flat to increasing. That tells me that I have a min at this x value. Let's take a look at Excel. Okay, so I have this all put into Excel, right? It wanted me to start between -10 and +10 and use increments of 0.1. So let's pull this up. I've got this in here. I have my inputs going from -10 all the way down to +10, or all the way up to +10. I put my f of x function, right? 6x to the 5th minus 15x to the 4th minus 20x cubed plus 9. And then I typed in my derivative function. Here's my derivative, 30x fourth minus 60x cubed minus 60x squared. And that's what I have here. I just typed in using cell referencing. Here's where my x values are. And I copied all those functions down. So I can see here that my derivative is positive. When my derivative is positive, it means that f of x is increasing. So I'm increasing. And if I want to use Excel to find the critical points, I'm going to keep looking. I know that if my derivative is equal to 0, that is going to tell me that I have a critical point. So I'm going to look here in my f prime of x, column C for me, and I see that when I come to x equals 0.8, my derivative is 4.6. And then when I get to x equals -0.7, I'm at a -1.6. So f of x is increasing when x is equal to -0.8. And then once I get to -0.7, f of x is decreasing. Because I have a sign change there, that's where I'm looking. I want to find the exact x value. The exact x value that is going to give me a derivative of 0. So I'm going to use solver. So I'm going to do data, and I'm going to do solver, and I want to force that. Okay. So now I want to continue on. I want to see if I have any other critical points. So using Excel, and so I can see here that because I changed, the derivative changed from positive to negative, means that f of x went from increasing to decreasing, and so that represents a maximum when x is equal to 0.73. All right, so now I'm decreasing, I'm still decreasing until I get to 0. Okay, x equals 0, my derivative is 0. That's another critical point. But I don't change signs, right? I'm decreasing, 0, decreasing. So that's neither a max or a min. Let's keep going. So I'm negative derivative. Negative means f of x decreasing, negative, decreasing, all the way until I get to x equals 2.7. My derivative is negative, means that f of x is decreasing, but by the time I get to 2.8, my derivative is positive, means that f of x is increasing. So because I had a sign change there, it tells me that I must have a minimum. I went from decreasing, and then it has to be flat in between there, to increasing. So I'm going to use solver. I'm going to force, I'm going to find the exact value where the exact x value where it equals 0. Okay, where did my cell go? Okay, I want to force that cell to equal 0, and I want to put that result right next to it in A129. Okay. And that gives me 2.7, and if I round that to another decimal place, it actually turns out to be, you can see it up here, 2.732, or I'm just going to say 2.73. There we go. Okay. So because the sign changes there, I know that at x equal 2.73, I have a minimum.